Hi, everyone, and good evening. I'm Dana Thompson, the director of the Brown Planetarium at Ball State University, and welcome to our next presentation from the Constellation crew. Today, we're focusing on the constellation Hercules, and we have our planetarium software here set up for Muncie, Indiana, right around sunset tonight, actually. And I'm joined today by all of the members of the Constellation crew. A couple of them are in the chat, but three of them are with us on screen here. So we have Alec. Hi, Alec. And Ricky.
Hi.
And Melanie.
Hi.
And we are going to teach you all about Hercules and look at some interesting things inside the constellation. Things that you can't see with just your eyes, that you need a telescope to help you see. But there are some things you can spot if you look really closely. So stay tuned for all of that. Right now, we're looking down on a part of campus. And if you're watching live with us and you know what part of campus we're looking at here in our simulation of the sky, go ahead and put it in the chat. We hope that you can put things in the chat and interact with us during this presentation as much as possible. So if you have any questions or any answers to our questions, put them in the chat. We also have some students who are helping out in the chat from the Constellation crew. We have Nicolette and Caleb there. So they'll be able to answer any questions that you might have. And we'll keep an eye on them here too. All right, so if you know what part of campus we're looking at, put it in the chat. If you aren't that familiar with campus, that's okay. Know that we are looking towards the southern horizon here. So we have in our simulation the S here that stands for south, the SE over here that stands for southeast, and the SW that stands for southwest. And they're along the horizon where the sky appears to meet the ground. And you might have noticed already that we have our moon in the sky. So if you're facing south outside tonight, around sunset, you can see a waxing gibbous moon. So a moon that's going to appear to get brighter over the next few days until it becomes a full moon. And we are looking down at a region of campus, and I don't think I see anyone commenting on where we are looking, but we are looking at the Northern Arena. So right here is the Northern Arena. All right, so if you're facing south outside tonight, then you can see the waxing gibbous moon. And let's see what else we can find. So let's go ahead and speed up time. And as we speed up time, the sun's going to set over on our right here in the west. The sun rises early in the east and sets in the west. And when it gets dark enough, you can start to see some bright objects and, of course, the stars. And right by the moon are two bright objects that we actually talked about a couple weeks ago in another Constellation crew presentation. So crew here, help me out, help us figure out what these are here. So we have one really bright object right by the moon, and then another even brighter object over to the right or to the west of that. And these look like stars, but they're not, right? They're planets. So we have this one here. What is that one? Do you remember?
I think that's Saturn.
Okay, so we have a guess for Saturn. So what about this one over here?
It's Jupiter.
So Jupiter and Saturn. So we know that the two planets that we saw in the sky around this location were Jupiter and Saturn, but let's see, what one is which? Saturn is farther away than Jupiter, and it's not as big as Jupiter. So it's going to look less bright in the sky. And I don't know, if you look really closely at these two, one does look a little bit brighter than the other. And this one over here looks brighter. So the bigger planet, the one that's closer to us, is going to look brighter in our sky. And that is planet Jupiter, the biggest planet in our solar system. And so that one, that would make this one over here the planet with the big rings, and that is Saturn. So if you're looking out by the moon tonight, if it's not cloudy anyway, you should be able to see Saturn and Jupiter in your sky take a look for that. But there's more in the sky, including the constellation we're focusing on, Hercules. And we have to look up a little bit higher in the sky, kind of by where we were looking last week. Last week we looked at the Summer Triangle, which is not a constellation, but what we call an asterism, another easily recognizable group of stars in the sky that makes a picture. And you can see that right here. So here's one star of the Summer Triangle. Here's another one. And here's the other one. So there's 3 bright stars right over your heads tonight after sunset that do make up a triangle. And we call it the Summer Triangle because it's up in the summer all night long. But our constellation of the week is right next to it. And Alec, you're going to help us out with finding that, right?
Yeah, so the first thing, like Dana said, to look at is the 3 bright stars that look like a triangle once you connect them. And if you look just slightly westward, you should see the Hercules constellation that we're going to talk about today.
Yeah, so kind of like in this area of the sky, right? But that's a big group of the sky or a chunk of the sky to look at. So a lot of people look for another smaller part of Hercules, this shape right here. And that's the shape in our virtual backgrounds, actually. It's a trapezoid. Some astronomers refer to it as the Keystone Asterism because it's another easily recognizable pattern in the sky that looks like a keystone. So let's highlight that. So off to the west of the Summer Triangle is our 4 stars that make the shape of a keystone. But again, as Alec said, there's more to the constellation than that. And so it includes more stars. And if you use your imagination, you might be able to see a guy out of these stars, right? And people can draw this in different ways. And there's a whole story behind it, right, Alec?
Yeah, so so Hercules is a Greek legend, sort of demigod sort of thing. And there are many different depictions of him in the sky. You can see there are slight differences between even the ones we've shown you, the one to the upper left and then the one in the actual sky. And that's because Hercules had to do what was called the 12 Labors of Hercules. And he did this to atone for some bad stuff he did earlier in his life. And the first one was that he had to slay the Nemean lion, and that's the headdress hat sort of thing he's wearing in the constellation art in the sky. So if you can kind of turn your screen upside down, you can see it. Then he's also wearing it in the bottom left picture. Another one of his labors is that he had to capture the Cerberus, which is the dog that guards people from leaving the underworld. And there are some weird things about the Cerberus. It's often depicted as just a 3-headed dog, kind of like in Harry Potter. The first one, the Sorcerer's Stone. But there are often snake heads coming out of it. So you can kind of see that in the top left picture.
Okay. What was the 3-headed dog's name again, Mel?
I think it's Fluffy.
Fluffy.
Very fitting.
Does not look very fluffy to me.
And Hercules is actually the 5th largest constellation in terms of general area.
Yeah, it's like as big as the Summer Triangle, and the Summer Triangle is made out of 3 different constellations, main ones anyway, and there's some other ones in there too that we didn't even cover because there's so much in that area of the sky. So it is pretty large, isn't it?
Mhm.
All right. So let's see that group of stars again without the picture here. So we have, again, the summer triangle almost right over your heads after sunset in the sky this time of the month. And then to the right or to the west, if you're facing to the right, if you're facing south, or just to the west, is the huge part of the sky that makes up the constellation of Hercules. And everything in this region of the sky, not just the stars that are being connected by lines here, everything in this region is a part of the constellation Hercules. I can't draw it out exactly with my mouse here, but around this area. And so if you were to look at anything in this area of the sky with a telescope, look at a piece of the sky, like say, let's look at this piece of the sky right here with a telescope, and we saw a star cluster or a galaxy there, then that would be inside the constellation of Hercules. So everything that we're going to be exploring in detail today is a part of the constellation Hercules. All right. So Paul made a comment in the chat saying that last night he saw Jupiter and he saw the moon, but maybe there was too much light pollution to see Saturn. And we actually are simulating some light pollution in this simulation of the sky here. And we're going to go ahead and zoom out here and turn off that light pollution. And as we do, you'll start to see some more stars and maybe even this band of light going across our simulated sky. That is our galaxy, or the plane of our galaxy. And we'll be able to see that even more as we launch from Earth. So we're going to go and leave Earth's surface. Let's zoom in a little bit and check out our solar system from space and eventually fly to some of the regions in Hercules, in the constellation of Hercules, that we're going to explore. All right, so here's the band of light there. That's the Milky Way, the plane of our galaxy. And we have our Earth here. We have the directions, sticking with our planet because there's not a north, south, east, or west in space. Crew, do you know how we navigate in space or have spacecraft navigate when we launch them to go to explore other worlds? So there, you can't use a compass. So what do we use? Do you know?
Don't know.
Hercules, no.
No, yeah, Hercules. We use the constellations. We use the stars. They're star trackers. They're cameras put on spacecraft called star trackers, and they look for certain patterns and they know how to navigate their spacecraft. So even though there's no up or down really in space and no north, south, east, west, we still have the constellations like Hercules up here. So we know that if we wanted to travel to a distant object, then we would go towards this pattern of the sky. But if we did that, eventually the star patterns would change. So let's actually go to that far distant region and see that. So all those stars zoom in by there. If we're traveling out in space in real life, we wouldn't have Hercules at our next location here because we see the stars as they appear from our location here on Earth. But space is huge, it's three-dimensional, and if you're at a different location of our galaxy, you would see all different star patterns, all new ones. So it's quite different depending on where you are. Can we actually take this trip in real life? No. We've barely made it outside of our own solar system, let alone to objects like this one here. And so here's a simulated view, and here's a real picture of this object. And this is a nebula. It's a cloud of gas and dust in space. And it's the result from a star like our sun dying. It is incredibly spherical. It's like one of the most round shapes in the universe, or the known universe. A lot of the literature will tell you that. And it's pretty large. It's larger than our entire solar system combined. But it's just this cloud of gas and dust. And it has this bluish tint to it. And sometimes the pictures can get confusing because you don't really know, is that what your eyes would see, or is that picking up light that is outside of our the range of light that we can see with our eyes, so maybe ultraviolet light or so on. But this picture, this simulation, and the picture we saw before is showing us that there's a lot of blues there that indicate there's oxygen. So there's oxygen in that region of space. So if we were on a space journey or something, if we were like in a science fiction film and trying to find oxygen, we might want to go to that nebula and collect some so that we could have our life support on the space station or spaceship. But we already got to another location in our journey, and another object in the direction of Hercules. And that is this thing right here. Let's zoom in a little bit more and see a real picture of this region of the sky. So we have the simulated view right here, and then a real image of this view, or this part of the sky over here. What do we have here, Ricky?
Well, this is M13, Messier 13. It's a globular cluster. It's just a big cluster of about 300,000 stars, all gravitationally bound to each other. One of the coolest things about this globular cluster is you can actually see it from Earth without any help from a telescope or anything like that. It's bright enough. It's got what we call an apparent magnitude of 5.8, which basically just means you can actually see it. It'll look like a star, kind of fuzzy around the edges instead of like a pinpoint like you're used to. It's called M13. It actually had a different name before that. It's NGC 6205. It was discovered by Edmund Halley in 1714. But 50 years later, Charles Messier put it on his list of objects to not look at because he only cared about comets. So he made this list of a bunch of objects that weren't comets, that kind of look like comets through the telescopes of the day. And this is just the 13th one he put on his list. So it's a huge cluster, about 22,000 light years away, if I remember right.
Yeah. So, and just a reminder of what a light year is. Does anyone here want to explain what a light year is? It comes out to be about 6 trillion miles.
Yeah, it's a long time.
Yeah, so a light year is the amount of, because light has a speed, so, and it's really fast. It's the fastest you can actually go. And it's the amount of time, or amount of distance that it would cover in a year's time.
Yeah, so a light year, even though it says year, it's a distance measurement, but it can give you some indication of time too. We won't get into that today, but it's the distance light travels in 1 year, and that's about 6 trillion miles. So how many light years away, Ricky, did you say this was?
About 22,000, between 22 and 25. We have it pinned down to.
So like 25,000 light years away or so. So we can actually, in our simulation, see our galaxy, the disk of our Milky Way galaxy behind it, and not much over here, which means it's really, really far away outside of the plane of our galaxy. All right. Anything else, Ricky?
That's it for that thing.
All right, we're going to say goodbye to that thing, which was M13, a globular star cluster, group of stars gravitationally bound together. And check out what else is out in our universe. So this is a simulation here. again, we can't go this far in real life, but we can see our galaxy, or what we think our galaxy looks like from the outside. And Melanie, you're going to tell us all about galaxies, right?
Yeah, I hope so. So our Milky Way is our home, but there are many, many others. There's three main categories. There's the spiral, the elliptical, and the irregular. We'll start with the spiral. I think most people are probably familiar with it since our own Milky Way is a type of one. So
Okay.
they are the most common.
Yeah, so hold on, Mel. We'll get to that in just a second, but just to give people an idea of what they're looking at here. So we were looking down at our spiral galaxy, which is the Milky Way. Sorry. And then we flew out to see our observable universe, which is filled with hundreds of billions of galaxies, or even trillions of galaxies. So that's what all those little smudges are, and that you can still kind of see them in the middle here. So every smudge here is a galaxy, and our Milky Way is just one of them. And so Melanie, you're starting with this one right here, right?
Yeah.
Okay, go ahead.
So that's what we call our spiral galaxy. They're the most common. So if you were to look at any point in that background area there, you would be most likely to see one of these. They're kind of flat like a pancake. So when you see the Milky Way in the sky, when we say you're looking into the plane, you can imagine it's kind of at eye level, like sort of like a pinwheel. You can see the little spiral arms coming off of that central structure there. So you might notice that the center looks a little bit more reddish yellow, and the spiral arms look a little bit more blue. And that's just based on the age of the stars that inhabit the area. So the center is a little bit more reddish yellow because it's primarily made up of older stars. So it's a little bit cooler, and the arms are more blue because they're made of younger, hotter stars. So spiral galaxies are extremely bright because they're made up of a lot of younger, bluer stars. So kind of a subcategory of spiral galaxies are what we call barred spirals, and that's actually what our own Milky Way is. We recently kind of reclassified it as a barred spiral, which is essentially the same as a regular spiral galaxy, but the center structure is more of a bar, kind of an elongated shape rather than just a circle.
All right, so like instead of this kind of nice circular area here, a barred spiral would have more of an elongated core here, right?
Right, yeah, and then the arms would extend off from either side of that. So the next type is the elliptical. They're less common than the spiral. I think they're about 10 to 15% of galaxies in the universe. Again, they look kind of similar in structure to the spiral galaxy, but you'll see they don't have any of the spiral arms, or any arms at all, actually. They're primarily made of older stars, which is why it looks a little bit more yellow rather than blue. And because of that, it's not quite as bright as the spiral galaxy. And actually, the largest and smallest galaxies in the universe are primarily elliptical, and we think that may be because of sort of interacting galaxies or disruptions from other galaxies that kind of distorts that nice round shape, which could be what causes that. And the third type is the irregular galaxy. It makes up about a quarter of galaxies. They're significantly smaller. The main thing that makes them irregular is that they don't have any real distinctive shape. They can just kind of look like a blob or a little splotch, a little blurry part in the sky. They don't have a real central point of mass to rotate around, which is why they don't get flattened. They can be more three-dimensional. And that's really the main three types. Of course, there's many, many subcategories within each of those. But on the bottom right, we can see what two galaxies would look like if they were interacting, and kind of maybe they would morph into one of these other types.
Okay, so we have spiral, elliptical, irregular, and interacting galaxies. So a lot of different types of galaxies, a lot of activity, especially really in this one here, the interacting ones. So this is when two galaxies collide into each other and the gravitational effects warp them. And they don't really collide rather than merge. Nothing really touches, we don't think, because there's so much space in between the stars that make up these galaxies. But some people do say collision or something, but really it's more of a merger. So the elliptical one to me kind of looks just like a star, like a really bright star. But there are actually stars in this photo here, and there are other galaxies in this photo too. So of course we have the large elliptical galaxy here, and if you can look closely, hopefully you all can see it if you're watching live with us. This galaxy here looks like a spiral galaxy. This down here kind of looks like another elliptical. But this object right here has these large points. And this object has some points too. So what's up with these all that seem to kind of have the same points that are in the same orientation, the same direction, the same shape even? That might not actually be out there in space. Space isn't really that uniform like that with those types of shapes. So we don't really see crosses in space. So that's actually not real. That's something that's actually due to the light from those objects. What happens to it when it passes through telescopes? So a telescope, when it collects light, that light has to pass by some metal bars that hold the mirrors of the telescope in place, and it interacts with that equipment in a way that it creates these spikes. They're called diffraction spikes. And there are some other things that you can see as a result of light being collected by a CCD or a camera chip to study these objects, but we don't see any of that here. Some people get diffraction spikes confused with CCD bleeding, which is a completely different thing. But anyway, those objects have spikes. Well, what are these objects and why are they creating these spikes? And the galaxies are not creating spikes, or these objects here that we know are galaxies, they're not creating those spikes. Well, actually the ones with spikes are stars, and the ones without spikes are galaxies. So everything you see in this picture here that has those spikes is a star, and everything else is a galaxy. The stars are closer to us in those faraway galaxies. Those stars are in our own Milky Way galaxy, so we can see them as points of light there. They kind of photobombed the picture of this elliptical galaxy. Since they're closer to us, they kind of come in and they're single points of this immense light. They come into the telescope in a different way than the farther away galaxies that have their light distributed a little bit more evenly and spread out. So I don't know, Crew, did you have anything else to add with that? Galaxies versus stars.
Maybe that's why people draw them that way.
Yeah. So, you have your picture of the star, right, with the 5 points, and yeah, stars don't have points. I don't know who actually thinks that. I'm not really sure. Did any of you think that growing up? That like real stars out there had points?
No.
Like the sun?
I guess I never connected the two.
No? Okay.
No.
Yeah, I didn't really connect them either. I just always thought of stars on sticker stars or star stickers for your homeworks or something was one thing, and then stars in the night sky were something else. But I think, maybe some people connected the two. So it's good to make sure that we all know that stars don't have those points in real life. Okay, so real pictures here. Taken, and then the little gap in the middle here is showing our simulation of our observable universe of galaxies, hundreds of billions of them. All right, so we are talking about galaxies and the constellation Hercules because there is a cluster inside Hercules, the constellation, called the Hercules Cluster of Galaxies, and you're looking at a real picture of it here. Melanie, were you going to say some things about this one first?
Yeah, so it's about 500 million light years away. So when we were talking about how big a light year is, that's a lot of miles. I don't want to do the math right now, but if you want, you can do it.
Wait, how many light years? I missed it.
500 million light years away,
500 million. Okay.
which is a lot.
That is a lot. So, okay, wait, what was another distance that we mentioned before? So the nebula that I was talking about, it's not mine, I don't own it. But the nebula I was talking about, Able 39, that blue spherical thing, is 7,000 light years away. Okay. Ricky, what was
M13,
your...
it was 22,000, between 22 and 25.
Okay. So 25,000 light years away. And then Melanie, what's this galaxy cluster?
500 million.
500 million. So 500 million versus 7,000 was the closest thing that we flew to that was outside of our solar system near our Milky Way galaxy. Okay, so quite a bit different. Sorry, go ahead.
No, you're good. So all of these sort of blurry little things that we can see are all galaxies. All of these are really, really dense with gas and dust. We see a lot of interactions going on, which is cool to see in real life. You can see the different sort of colors throughout. There's lots of blues and then more reddish colors. And again, that's just really what's making up those galaxies, what age of stars and temperatures, which are correlated. So the bluer they are, the younger, the hotter, the bigger the stars are. And the more red, they're a little bit cooler and dimmer and older.
Less hot.
Less hot. Still pretty hot.
Still really hot. Just less hot, yeah. All right, so in the previous picture we looked at, we saw an elliptical galaxy and saw some stars in that field of view, as well as some other galaxies. In this photo here, do we see any stars? Remember, the stars will have points, those diffraction spikes. I don't see any. That other galaxy was maybe a little bit closer to us than this cluster. Because like if we're looking at this many galaxies, we are probably looking at a very small patch of the sky. Really, really far away. But with long exposure, with long exposures, we can capture the light from those distant galaxies and see just a handful of the hundreds of billions of galaxies in our universe, which is quite amazing. So people watching, can you spot any... So Melanie pointed out that there's a lot of interacting galaxies here, but what about any spiral galaxies? I don't know if you can try to zoom in here. If you're watching on your phone, or if you're watching maybe on a larger screen, you can see them. But any spiral galaxies here, any elliptical galaxies, or ones that just kind of have a weird shape?
That one in the lower rightish is pretty neat looking. It's got like a bunch, looks like a cloud of dust came through.
This one?
Yeah.
Yeah, this looks like 3 that kind of maybe are interacting. Over here, there's like another group of 3 that might be interacting. And there's some disc-shaped ones that are probably spirals, right? Or maybe irregular. It's really hard to see. They're pretty fuzzy. And actually, cataloging all of these different types of galaxies takes a lot of work. A lot of scientists want people to be able to help them catalog the galaxies so that they can do science with that information. So there's a whole what was called citizen science project on zooniverse.org that Nicolette, one of our Constellation crew members, posted some information about in the chat. So if you want to help catalog galaxies and contribute to real science, go to that link there for Zooniverse and help scientists out, because it's it's a lot of galaxies to look through. It takes a lot of time, and computers not so good at figuring out what pictures look like, and all of that yet anyway. So it really needs people. It needs the human component. Absolutely anyone can do it. You don't need a degree or anything like that. All right, anything else, Mel?
No, that's really all that I had.
Okay. All right. So let's see. Alec, could you do a quick recap of how to find Hercules in the sky? Because we looked at a lot of objects within the constellation of Hercules. We looked at a nebula, a globular star cluster, so that group of stars, and then also galaxies, like this cluster of galaxies out in our far distant, or out far in our universe. But how do we find the constellation in our sky?
Yeah, so the first thing you want to look for is there are going to be 3 very bright stars somewhat close to each other in the sky, and if you connect the dots, you're going to see a triangle. That's the summer triangle. And if you look just by it, slightly westward, that's where Hercules is.
So right around in here. And you look for a trapezoid shape in the stars. It's also known as the keystone. Another asterism, another easily recognizable pattern of the stars.
Summer keystone.
And then connect more stars, and you got the constellation of Hercules. All right, any final thoughts, crew? All right, for those watching, we are going to put a link to a star map or a sky map in the chat so that you can print it out or get it on your phone and try to find some of these constellations that we've been talking about with the Constellation crew. What are we doing next week, crew? What do you want to do? I think I said one, but what are you thinking?
Let's see, Pegasus is up next.
Yeah, so we have Pegasus up next. Is that still good?
Yeah, Pegasus sounds good.
Okay, so we're gonna talk about Pegasus. Cool. Yeah, it's pretty cool. It's easy to find. It took me a long time to find my constellations in the sky. I had the Summer Triangle down, which isn't even a constellation, but when you can find it, you can find 3 constellations. And then I could find Orion the Hunter, but not too much else. Pegasus, pretty easy. We're going to go over it next week, and there's a lot of really cool things inside Pegasus, the constellation of Pegasus, like exoplanets, planets going around other stars, so strange worlds out there in our galaxy. So stay tuned for that, everyone. But for now, have a great evening and a wonderful weekend, and we'll see you next week. Bye, everyone.